Welcome to lesson 3. In this lesson, I am going to discuss how you can interface servo motor with Arduino. So first question that arises, that is, what is servo motor? Servo motor is a type of motor which usually provides precise control of angular movement. Suppose you want to control or you want to take your motor to a certain angle, that time and in those applications you need a servo motor. So servo motor is used in many kinds of robots, robotic cars, robotic toys, and some special servo arrangements like pan tilt servo motor and gripper servo motor. These are few examples and where we can use servo motors. Normally, this is the image of a servo motor where I am using a Tower Pro micro servo. This kind of servo motors have three wires, one for VCC, another for ground, and third one is for signal. And we can connect these servo motors directly with Arduino. These servo motors have built-in controller which gets a position feedback from the motor movement, and through that the servo motor controller controls the angle. So how we can control a servo motor, or how an Arduino Uno board can send pulses to servo motor? Look at this image. There are three signals. So servo can be controlled using these signals. So these are basically PWM signals. So the minimum pulse, where the pulse width is of 1 millisecond, then the servo moves to 0 degree. If you want it to move to the middle position, that is 90 degree, your pulse width should be of 1.5 millisecond. And for 180 degree movement, you have to give a pulse width of 2 millisecond. Now, you can ask me that what is the total time period? Let me give you that info also. Servo motors can be controlled using PWM signals. So if you want to interface servo with your Arduino Uno board, you need these 6 pins, 3, 6, 5, 9, 10 and 11, because these pins are capable to generate PWM signals. And the required frequency, which is fixed for every servo motor, is 50 Hz. That means the total time period becomes 20 milliseconds. So here, if these pulses, the signals you are seeing here, these signals have a time period of 20 milliseconds. So now if I calculate for 0 to 180 degree movement, there is an increment of 1 millisecond in pulse width. So if I convert that 1 millisecond into microseconds, so it becomes 1000 microseconds for 180 degree movement. Then for per degree movement, you need to either increment or decrement the pulse width by 5.5 microseconds. That is our calculation. So these complicated calculations, I am telling you these in details, but there is a library called Servo, which is used by Arduino Uno board, and the library does everything. So what is the library? In Arduino IDE, there is a servo object. So whenever we use a library, we need to include servo.h, and then immediately after that we have to create an instance like servo my servo. Look at the second line. What I have written is creating instance. So we have to create an instance servo my servo. When you have created the instance, now you can use the properties and behavior of servo object by simply writing my servo instead of servo. So there are two main functions. One is write, where you can write the position in degrees, and servo will move. How? My servo dot write within bracket 180 degree. If you write this single statement, servo will move to 180 degree. If you want to move or if you want to rotate the servo to 90 degree, just write my servo dot write within bracket 90. This is the simple statement. Another function is there, that is the attach pin. Where you have connected your servo, you need to tell the compiler or you need to tell the Arduino that. And that's why normally we write myservo.attach within bracket the pin number we are using for this servo motor interfacing. And where we write this statement? Inside void setup, because this is where the statement where we are configuring the pin. Now remember carefully, when we are writing myservo.attach within bracket the pin number, that means we don't need to write pin mode, because the attach function does everything. So we just have to write myservo.attach within bracket the pin number we are using. Then inside void loop we can write myservo.write or everything. It can be other, like I have given you an example of servo myservo. You can put your name instead of myservo. So whatever you are going to use, you have to stick to that. That means what I am trying to say is, you can put your name or you can put any name to your servo motor instance. So here I'll be doing an experiment, and my objective is to create a sweeping motion of servo from 0 to 180 degree. And how I'll do that? I'll use an incremental loop where servo will go to 180 degree from 0, and then I'll give some delay, and then I'll be using a decremental loop where it will come back to 0 from 180 degree. That's it. So now let me show you my circuit. Here I have used one Arduino Uno board along with a servo motor. So I have told you that there are 3 pins in a servo motor. One is for VCC, that is denoted as red color wire, that I have connected to 5 volt. The black wire should be connected to ground, and I did that. And there is the signal wire which I have connected to pin number 9. Now you know that 9 can handle PWM signals, so that's why I have connected it to pin number 9. Now let's do the connections. So this is my setup. I have one Arduino Uno board, one servo motor. Here I am using SG90. This is a different manufacturer. Let me show it to you. It's by Tower Pro, but SG92R, and this is the one attachment. And there are 3 wires, as I have told you. The red color is VCC, this brown one is ground, and this is the signal pin, the yellow color. So these are 3 wires. I have 3 wires, 3 jumper wires to connect it with Arduino. Let me do the connections. So let me put it through these holes. Now if you look that I'm using one yellow wire, and that is connected to the orange wire of the signal pin of servo, and I have connected it with pin 9. Now if you look at it carefully, the blue one is ground, connected to ground, and the green one is connected to VCC, and my connection is complete. Now let me connect the USB cable. I have already written the program and saved the program as servo motor. So this is my library. This is I have included servo.h as the library whenever you are using servo motor. And this is the instance, servo myservo. Servo myservo. So myservo is an instance of object servo. And this is a variable, position variable. I have initialized as an integer and initialized as 0. This is an integer type variable. And inside void setup, I have configured the servo which I have connected to pin 9. So what I have written is myservo.attach within bracket 9. This is the simple void setup. Now come to void loop. Here this is the incremental loop where position goes from 0 to 180 degree, and I am using a delay to successfully put the servo in position. This delay is needed, otherwise there will not be a smooth motion. And here I am using half a second delay, so that the servo will hold this position for half a second, 180-degree position for half a second. Then I am using a decremental loop from 180 to 0, see position minus minus. Here I have written the same thing, my servo dot write, and this position will be hold for half a second. This is my simple program. I have already saved it. Let me check my Arduino is at COM5. Now what I'll do is I'll upload the program. One thing you can do, you can go to examples and servo and go to this sweep example. You can also try this out. I have got my reference from this program only. The same thing I did, but what I have included is the holding time for half a second. Otherwise, these two programs are same. Look at the incremental loop. Yes, another thing is changed, that is in this example they have used a delay of 15 millisecond. I have used 5. Now I'll upload my program. Arduino is at COM5. Let me upload. First it will get compiled, then the program is getting uploaded. The program is getting uploaded, done uploading. Now see the servo movement. It is coming back to 0, then 180 degree, then coming back to 0, then 180 degree, again coming back to 0. Let me put this servo in front of my camera. See it carefully. 0 to 180 degree, a sweep movement. Not pure 180 degree, because these are very low cost motors. So you'll get some movement, but not pure 180 degree. In the next lesson, I'm going to discuss how you can interface Bluetooth module HC05 with Arduino.